Welcome to TensorFlow, flexible, scalable, open source machine learning, basic to advanced training. In this training, we will go over introduction to TensorFlow, we'll go over basics of TensorFlow, then intermediate level of TensorFlow, some advanced TensorFlow, and also practical applications and projects for using TensorFlow. We'll also go over further learning and resources where you can pick up more things and find stuff on your own on the TensorFlow documentation on its websites or other sources. We'll wrap up with summary of what we have learned in this particular training. While going through this course, if you come across something that you don't understand or have some comments, please leave the comments and we'll get back to you as soon as possible. So let's start with introduction to TensorFlow. But before we start introduction to TensorFlow, we need to know what machine learning or machine learning for TensorFlow is. So let's start with machine learning and let's go with the definition first. The definition of machine learning by book is machine learning is subset of artificial intelligence. So the AI, one of the main sub-branch is machine learning that involves the development of algorithms and statistical models that enable computers to perform tasks without explicit programming instructions. So like traditional programming where you would program things to do from X to Y, Y to Z, it's the machine that actually learns from different algorithms and data and then makes its own decisions. And you are the one who's going to train using TensorFlow and creating your models to do that. It focuses on the study and construction of the system that can learn from and make predictions or decisions based on data. So everything is related to data. So you can create algorithms and then feed it data and then it will learn by itself. And then in future, if you want to make some predictions, you provide it to this particular system and it will make decisions for you. Now, what are different types of machine learning? We have three different types. The first one, supervised learning. The second, unsupervised learning. And third, reinforcement learning. In supervised learning, the algorithm learns from labeled data, which means that each input data point is associated with a corresponding target label. The goal is to learn a mapping from inputs to outputs based on this labeled data. The key characteristics for this is, as I mentioned, the labeled data. The training subset consists of input-output pairs, where the output, the label, is provided for each input. The training objective, the algorithm aims to learn a mapping or relationship between inputs and outputs, often represented by a hypothesis function. What are the types of problems? So supervised learning is used for tasks like classification, predicting categories or classes, and regression, predicting continuous values. Examples of this can be if you get spam in your email, so spam detection, image classification. You probably have seen the classic example of classifying a dog and a cat. So that way you can kind of use to a broad variety of applications out there. Sentiment analysis, if you get a bunch of emails, you want to check the sentiment of your customers. If they have some positive feedback or a negative feedback, you can use this for that. And house price prediction. Everybody wants to buy a house and you can predict price of when is a good time to buy a house. The second one, unsupervised learning. In unsupervised learning, the algorithm learns patterns and structures from input data without explicit supervision or labeled responses. The goal is to explore and uncover hidden patterns or representations in the data. The key characteristics, unlabeled data. The training dataset contains only input data without corresponding output labels. That's why it's called unsupervised. There's no output to compare it with. Training objective, the algorithm aims to find inherent structures or relationship within the data, such as clusters, associations, or anomalies. The system itself makes the classification. The types of problems, unsupervised learning is used for tasks like clustering, grouping similar data points, dimensionality reduction, compressing data while preserving its structure, and anomaly detection, which is identifying unusual patterns. Examples for this are customer segmentation, recommendation systems, anomaly detection in a particular network traffic. So that's what this unsupervised learning can be used for. The third one, the reinforcement learning. Reinforcement learning involves training agents to make sequences of decisions in an environment to maximize cumulative rewards. The agent learns through trial and error by interacting with the environment, receiving feedback in the form of rewards or penalties. The key characteristics are agent-environment interaction. The learning system, the agent, interacts with an environment, taking actions and receiving feedback, which are rewards or penalties, based on those actions. Delayed feedback, the consequences of an action may not be immediately apparent, requiring the agent to learn through long-term exploration and experience. Training objective, the goal is to learn a policy or strategy that maximizes cumulative rewards over time. What are types of problems? Reinforcement learning is used for tasks like game playing, robot control, and autonomous decision making in dynamic environments. What are the examples? Training game playing agents, example is one AlphaGo. Then there's robotic control, self-driving cars. These are all examples of reinforcement learning. Each type of machine learning has its own set of algorithms, techniques, and applications, and the choice of the appropriate type depends on the nature of the problem and the availability of labeled data. Machine learning has a wide range of applications across various domains, revolutionizing industries and driving innovation. Here are some of the notable examples of machine learning applications in different domains. We'll start with healthcare. Medical diagnosis. Machine learning models can analyze medical images such as X-rays, MRIs, and CT scans to assist in diagnosing diseases like cancer, pneumonia, and diabetic retinopathy. Drug discovery. ML algorithms are used to predict molecular activity and identify potential drug candidates, speeding up the drug discovery process. Personalized medication. ML techniques analyze patient data to tailor treatment plans and predict individual responses to medications, improve healthcare outcomes. In finance, fraud detection. ML models detect fraudulent activities in banking transactions by analyzing patterns and anomalies in transaction data, helping to prevent financial losses. Algorithmic trading. Machine learning algorithms analyze market data to identify trading opportunities, optimize investment strategies, and automate trading decisions. Credit scoring. ML models assess the creditworthiness of individuals by analyzing their financial history, helping lenders make more accurate lending decisions. Retail and e-commerce. Recommendation systems. ML algorithms analyze customer behavior and preferences to provide personalized product recommendations, enhancing the shopping experience and increasing sales. Demand forecasting. Machine learning models predict future demand for product based on historical sales data, optimizing inventory management and supply chain operations. Price optimization. ML techniques analyze market dynamics and customer behavior to optimize pricing strategies and maximizing revenue. Manufacturing. Predictive maintenance. ML algorithm analyzes sensor data from industrial equipment to predict equipment failures and schedule maintenance proactively, reducing downtime and maintenance costs. Quality control. Machine learning models inspect and analyze product defects in real time, ensuring product quality and reducing defects in manufacturing process. Supply chain optimization. ML techniques optimize production schedules, inventory management, and logistics operations to streamline the supply chain and improve efficiency. Transportation and logistics. Autonomous vehicles. ML algorithms power self-driving cars and autonomous drones by analyzing sensor data to perceive the environment, making driving decisions and navigate safely. Route optimization. Machine learning models optimize transportation routes and delivery schedules to minimize fuel consumption, reduce delivery times, and lower transportation costs. Traffic management. ML techniques analyze traffic patterns and predict traffic congestion to optimize traffic flow, improve road safety, and reduce commute times. Natural language processing. Language translation. ML models translate text and speech between different languages with high accuracy, enabling cross-cultural communication and breaking down language barriers. Sentiment analysis. Machine learning algorithms analyze text data from social media, reviews, and customer feedback to extract sentiment and gauge public opinion about products, services, or events. Virtual assistants. ML-powered virtual assistants like Siri, Alexa, and Google Assistant use NLP techniques to understand and respond to natural language queries, perform tasks, and provide information. These are just a few examples of how machine learning is transforming various industries and domains. As machine learning continues to advance, its application will likely expand further, driving innovation and shaping the future across diverse sectors.